We'll go with module 5 in that 9th A. Find the rank of one, a matrix called 1 2 3 2 2 3 5 1 1 3 4 5 by elementary row transformation. So when this kind of problem is given for you in your exam, so when you start with solution, consider the given problem as a matrix A equal to 1 2 3 2 2 3 5 1 1 3 4 5. So afterwards, first thing you should observe that whether the leading entry, the first row first element is called as leading entry, that should be non-zero. That should be always non-zero. And below that entry, if you have, in case other than 1, if in this problem it is already this leading entry is itself 1. In case if it is not equal to 1, means other than 2 3 4 it may be having. If you observe below that value as 1, interchange that interchange that whole row with that row, then make sure that. So afterwards make these make below the leading entry should be 0. By using row elementary operation, make the below the leading entries as 0. Then the second row second element will be called as a leading entry. Afterwards make this as non-zero and make the below entries as 0. So the diagonal element should be a leading entry called 1. The diagonal elements of the matrix should be equal to 1 to find the rank of the matrix. The non-zero rows is called the number of rank. The number of non-zero rows gives the rank of the matrix. Now if I go with an operation called row elementary operation, as the R1 I am restricting R1, I am not making any change with row 1. This is called as row 1, this is called as row 2, this is called as row 3. So I am not making any changes with R1, so I'll note down R1 as it is, and I am making the changes in R2, so that's why I am making that as R2 dash, and I am making changes in R3, so I am making that as R3 dash. R2 dash changes to R2 minus 2 times of R1. Using R1 I am making operation, so 2 minus 2 becomes 0. So the R1 is multiplied throughout by 2, and this R1 is subtracted with R2. So therefore 2 minus 2 becomes 0. 3 minus 4 becomes minus 1. 5 minus 6 becomes minus 1. 1 minus 4 becomes minus 3. So 1 R3 dash changes to just we have 1 minus 1. 1 minus 1 should be become 0. So therefore R3 minus R1 I am going to do. So therefore 1 minus 1 is 0. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 2 is 3. 5 minus 2 is 3. Now this value is non-zero. I will keep as it is. I am making this value below the that value should be 0. To make that as 0, I am making change in R3. So making that as R3 dash changes to R3. We have opposite sign. So R3 plus R2 becomes 0. So I am restricting first row and second row. So retain as it is. So keeping R2 as it is. So making changes in R3. 0 plus 0 is 0. 1 minus 1 0. 1 minus 1 is 0. 3 minus 3 is 0. So I told you that the leading entry should be 1, right? Here we have minus 1. So I am putting an operation for R2 dash changes to R2 is multiplied by minus sign. So minus R2. Therefore 1 2 3 2 0, 1, minus into minus plus 1, minus into minus plus 1, minus into minus 3, minus into minus 3 is 3, so the last row is 0. Therefore the number of non-zero rows are 1, 2. Therefore rank of A is 2. Rank of A is what? 2. Go with next problem. 9th B. Apply Gauss-Jordan method to solve the system of equation. So the given system of equation is 2x1 plus x2 plus 3x3 equal to 1, 4x1 plus 4x2 plus 7x3 equal to 1, 2x1 plus 5x2 plus 9x3 equal to 3. So if I go with the solution, so to start with the solution, the given system of equation is nothing but it is of the form Ax equal to B. It is of the form Ax equal to B. What is A, what is X, what is B? A is a coefficient matrix, X is an variable, unknowns, B is a constant column matrix. So what is A here? A is what? A is what here? 2, 1, 3, 4, 4, 7, 2, 5, 9. This is what A. What is X? What is X here? X is a column matrix called unknowns, x1, x2, x3. And what is B? A matrix B is constant matrix called 1, 1, 3. So this is and a system of equation can be generated in an equation of the form Ax equal to B. Now I am going to write an augmented matrix. So what is that augmented matrix? It is nothing but A is to B. So write down A is to B. You know what is A, what is B. Note down that 1, 2, 1, 3 is to 1. 4, 4, 7 is to 1. 2, 5, 9 is to 3. So the given problem is of apply Gauss-Jordan method. So what is Gauss-Jordan method? Gauss-Jordan method is a method to reduce this augmented matrix to a diagonal matrix. By using row, by using only row operation. So now the leading entry here is non-zero. Make the below entries as 0. So to make that entries as 0, I am keeping R1. I am keeping R1 and making the operation for R2 and R3. R2 dash and R3 dash. I am disturbing R2 and R3 dash. As we have R1 is 2, so if I multiply by R1 as 2, so it becomes 4. 4 minus 4 becomes 0. So therefore R2 dash changes to R2 minus 2 times of R1. Similarly R3 having 2 and R1 is also 2. So just subtract those two values. So R3 minus R1 becomes 0. So keeping the first row as it is, I am disturbing the remaining two rows. 4 minus 4 becomes 0. 4 minus 2 becomes 2. 7 minus 6 1. 1 minus 2 minus 1. 2 minus 2 0. 5 minus 1 4. 9 minus 3 6. 3 minus 1 2. So if we observe any common multiples, we can divide that by a common multiple. I am going to disturb R3 as R3 by 2. I am going to divide R3 by 2. Divide by divide R3 by 2. So we are going to get 2, 3, 1, 3 is to 1, 0, 2, 1 is to minus 1, 0, 2, 3, 1. So now what I am going to do means, here keeping second row as it is, fix. I am fixing the second row now. I am going to fix the second row and make these two values as 0. Make these two values as 0. So I am disturbing R1 dash and R3 dash. So R1, so if I multiply R1 by 2, 2 minus 2 becomes 0. So therefore 2 R1 minus R2. So similarly, here R3 is what here? R3 minus R2 if I do. 2 minus 2 becomes 0. So keeping the constant row as second row, 2 into R1. I am multiplying R1 by throughout by 2 times. So it becomes 2 2s are 4. 4 minus 0 is 4. So 2 minus 2 is 0. 6 minus 1. 6 minus 1. 6 minus 1 5, 2 minus into minus plus, 2 plus 1 becomes 3, 0, 2 minus 2 0, 3 minus 1 2, 1 minus of minus plus 2. So now fixing the third row, you can divide by 2, nothing to worry. You can first divide by 2 and then you can find out. R3 is divided by 2. So we get what? 4, 0, 5 is to 3, 0, 2, 1 is to minus 1, 0, 0, 1, 1. Now fix R3. Fix R3. Fix this and make these two values as equal to 0. Make these two values as equal to 0 by using R3. By using R3. So I am disturbing R1 dash and R2 dash using R3. So the fixed values of what? 0, 0, 1, 1. So here I should multiply R3, R1 minus 5 times of R3 and R2 minus R3, that's all. So 4 minus 0, 4 itself, 0 minus 0 itself, 5 minus 5 is 0, 3 minus 5, 3 minus 5 is minus 2. Next 0, 2, 1 minus 1, 0, minus 1 minus 1 minus 2 is to minus 2. So now the system of equation is 4x equal to minus 2, 2y equal to minus 2, 3z, here x1 and the unknowns are x1, x2, x3 is equal to 1. It is just x3 equal to 1. So therefore I came to know x1 values minus 1 by 2, x1 equal to minus 1 by 2, x2 equal to minus 1, x3 equal to 1. So this is the way of solving Gauss-Jordan method. So I have reduced this to diagonal matrix and converted to system of equation. Then I got the values of unknowns. Now we shall go with next problem, 9C. Find the largest eigenvalue and the corresponding eigenvector of the matrix A equal to 2 0 1 0 2 0 1 0 2 by power method. It is called Rayleigh's power method. By power method, using they have only provided the initial vector. Using the initial vector 1 0 0 transpose 1 0 0 transpose. So go with the solution. Consider the given matrix A and just multiply this initial vector with that matrix. So I'm going to find out an iterative method called AX0. I'm just multiplying the matrix multiplication. I'm going to do just matrix multiplication. 2 0 1 0 2 0 1 0 2 is multiplied with a column matrix 1 0 0. Make use of calculator. You will get 2 0 1 2 0 1. So out of these in this column matrix, out of these values, so take out divide by largest value. Here 2 is the largest value, so you are going to divide each value by 2. So 2 by 2, I am going to take out the 2. 2 by 2 becomes 1, 0.5. So which is nothing but a first iterative called eigenvalue lambda 1 and x1 eigenvector. So now I am going to find out ax1. So ax1, again a into this value x1, I am going to multiply. I will get back with 2.502. So here again 2.5 is the largest value. Divide by that value 0.8. So I got second iterative as lambda 2 x2. So find out ax2. Multiply a with x2. So I am going to get a value called 2.8 2.6. So which is equal to 2.8 divided by a largest value 2.8 0.93. So the eigenvalue 3 lambda 3 and x3 I got. So now find out ax3. So ax3 is nothing but 2.93 2.86. I think you all are understanding what I am doing. I am taking a, I am multiplying with x3, taking a value, a matrix with multiplying with x3 matrix. X3 is known earlier. So which is equal to here 2.93 is highest value, divide by that value 0.98. So this is nothing but lambda 4 x4, fourth iterative. So ax4, I'm going to find out ax4. So I got ax4 as 2.98 2.96. So which is 2.98 is highest value, divide by that value I got 0.99. So lambda 5 x5. So multiplying with the ax5 I get 2.990 2.98. so which is equal to 2.99 multiplied with 10.997, so which is lambda 5, sorry, lambda 6 x6. When I observe the values of lambda 5 and lambda 6, already it is approaching, so I am not going to leave that part. I am not taking any advantage here. I am going with one more iteration to see the approximation, to see the one more approximation, whether the value I am going to get is approximate or not. I am going to find AX5. So AX5, when I multiply AX5, I am getting the value 2.997. So 2.9970, 2.994, which is 2.997 is highest value. So when I take out that, I am left out with 10.999. So when I observe these two values, is one in the error is very less error, 0.002 I am getting. So I will stop at this stage and I will define the largest eigenvalue and eigenvector. The largest eigenvalue is I can approximately say that it is 3, and eigenvector approximately as 101. So lambda equal to 3 and x equal to 101. So approximately you can say that approximately, it is not exactly equal to, approximately equal to 3 and 3. The x value is 101. So this is the way of solving eigenvalue and eigenvector by Rayleigh's power method. You can use calculator, just pressing equal to, you will get the answer. That's all. So next we shall go with option problem here, 10th A. Solve by Gauss elimination method. So the given system of equation is x minus 2y plus 3z equal to 2, 3x minus y plus 4z equal to 4, 2x plus y minus 2z equal to 5. So it is a very simple problem. If I start with the solution, first write down the augmented matrix. So I have explained you the concept of system of equation by using Gauss-Jordan method. Similarly, consider an augmented matrix here. So A is to B is what here? A is nothing but a coefficient matrix called 1, minus 2, 3 is to 2, 3 minus 1, 4 is to 4, 2, 1 minus 2 is to 5. So here what is the procedure of solving by Gauss elimination method means you should make sure that the given augmented matrix is upper triangular matrix. If you make sure that the upper triangular matrix, then convert that to a system of equation, you will get the solution for the given system of equation. So by using only row reduced row operations. So here the leading entry is non-zero, not equal to 0. Make these two elements as 0 by using R1. So I am fixing R1 here. So I am making an operation for R2. I am disturbing R2 dash and I am disturbing R3. So I am making that as R1, R2 dash and R3 dash. R2 dash changes to R2 minus 3 times of R1. R3 dash changes to R3 minus 2 times of R1. So I am going to get 1 minus 2, 3 is to 2. So 3 minus 3 becomes 0. 5 minus 5 minus 2, 0, 5 minus 8, 1. So here next my aim is to make this value as 0, as this value is non-zero. Fixing this second row, make that element as 0. So here r3 dash is disturbed, r3 minus r2, just r3 minus r2 I am doing. 1 minus 2 3 2 0 5 minus 5 minus 2 0 5 minus 5 0 minus 8 plus 5 is minus 3 uh, 1 minus into minus 2 is 3. So 1 plus 2 is 3. Now convert this to system of equation. So this system of equation becomes x minus 2y plus 3z equal to 2, 5y minus 5z equal to minus 2, minus 3z equal to 3. So from this equation z is 3 by minus 3, which means minus 1. I got the value of z as minus 1. I got the value of z as minus 1. Substituting the value of z as minus 1 in the above equation. So 5y minus 5 into minus 1 equal to minus 2. Simplifying this, 5y equal to minus 2 minus 5. Minus 2 minus 5. Minus 2 minus 5 is how much? So which is equal to minus 7. That implies y equal to minus 7 by 5. Minus 7 by 5. I got the value of y and z. Substituting the value of y and z in the above equation. So you can name this as 1, 2. So equation 2 here, equation 2. So here equation 3 implies x minus 2 into minus 7 by 5 plus 3 into minus 1 equal to 2. So simplifying this, x equal to 2.2 we are going to get. X equal to 2.2 and y equal to here minus 1.4. So therefore I got the values of x, y, z. Therefore x equal to 2.2, y equal to minus 1.4, z equal to minus 1 is the required solution of the given system of equation. This is what I have done. I have reduced the given matrix to upward triangular matrix. This is called upward triangular matrix. So there is a chance of this value becomes 0 also. So nothing to worry there. The next problem, 10th, we solve the system of equation by Gauss-Seidel method. So they have given the system of equation. We should solve this by Gauss-Seidel method. The Gauss-Seidel method says that the linear entry, the first row, first element should be always greater than other two values, the sum of other two values. So 20 should be greater than 20 is greater than 3. Here 20 is greater than 3 plus 1, again 4. 20 is greater than 5. So in case if it is this leading entries called the diagonal elements is not greater than 0, we should rearrange that values according to that column. Look at that and change over that. In this given problem, I came to know that the given system of equation is diagonally dominant. So we can rewrite that as statement. The given system of equation are diagonally dominant dominant. So diagonally dominant means the diagonal element should be greater than the sum of the other two elements, that's all. And hence we can rewrite that as, and hence we rewrite as form x equal to 1 by 20 times of 17 minus y plus 2z, y equal to 1 by 20 times of minus 18 minus 3x plus z, z is equal to 1 by 20 times of 25 minus x 2x plus 3y. So initially we will start with 0 0 0. So initially we are going to start with 0 0 0. So I'm going to construct a table here, approximations. So x value, y value, z value. So in first approximation, what way I'm going to get, let us see. Initially consider, if they don't give any initial value, you can initially consider the x value as 0, y value as 0, z value as 0. Substituting in initial values, in here y equal to 0, z equal to 0, 17 by 20. 17 by 20 is nothing but what? 0.85. Similarly, substitute the value of x and z. So you are going to get minus 1.0275. So what is the value of x? X is now 0.85. 0.85. It means x upon 0, y upon 0. Now this becomes x upon 1, y upon z upon 0. This is x upon 1, y upon 1. Initial, first approximation like that. Z value is 1.0109. So go with second approximation. So now the values are x, y, z as whatever the first approximation we got. That values will be substituted for x, y, z. So therefore x value is 1.0025, y value is minus 0.998, z value is 0.998. The third approximation is 1, approximately 1. So this is also approximately minus 1. This is also approximately equal to 1. Therefore x equal to 1, y equal to minus 1, z equal to 1 is the required solution. For the given system of equation by using Gauss-Seidel method. So just substitute the initial values, that's all, in x, y, z. Consider the problem, reduce the matrix A to the diagonal form. So to reduce, I require to find the diagonal form of this matrix A. So how to find out the diagonal matrix of the given matrix? So first find the eigen values. First find the eigen values by using CH equation, means characteristic equation. Go with the solution. The characteristic equation is given by determinant of A minus lambda I equal to 0. So just subtract the diagonal values by lambda. So we are going to get minus 1 minus lambda, 3 minus 2, 4 minus lambda equal to 0. Expanding this, we get minus 1 minus lambda, expanding this determinant 4 minus lambda, minus into minus plus 6 equal to 0. So simplifying this, I got a quadratic equation lambda square minus 3 lambda plus 2 equal to 0. Solving this, I got the roots as lambda equal to, therefore lambda equal to 1 and 2 are the eigenvalues, eigenvalues of the matrix A. Now you are going to consider a system of equation. Now consider A minus lambda I into x, where x is unknowns, equal to 0 matrix, where x is unknown equal to 0 matrix. So therefore A minus lambda means what? Minus 1 minus lambda, minus 1 minus lambda, minus 1 minus lambda 3, minus 2 4 minus lambda is multiplied with a matrix unknown xy, two unknowns xy, 3 and 0 0 for column matrix. Now expanding this matrix, a system of equation, we are going to get minus 1 minus lambda x plus 3y equal to 0, minus 2x plus of 4 minus lambda y equal to 0. Now using these two eigenvalues as case 1, case 2, substituting in a system of equation in star, so we are going to get an corresponding eigenvectors. We are going to get an corresponding eigenvectors. So case 1, when lambda equal to 1 in star, so you are going to get an equation of the form minus 2x plus 3y equal to 0 and minus 2x plus 3y equal to 0, right? So therefore x1, solving this equation, x equal to what and y equal to what, we are going to get so it is 2x equal to 3y. That means if x equal to 3 and y equal to 2, we are going to get the solution. So x by 3 equal to y by 2. So therefore the corresponding eigenvector for when lambda equal to 1, therefore the x1 equal to 3 2, a column matrix 3 2 is the eigenvector to lambda equal to 1. So go with case 2, let lambda equal to 2 in star. If you substitute, we are going to get, consider one of the equation, minus 3x plus 3y equal to 0. So that implies what? X equal to y. So that implies what? X by 1 or y by 1. So therefore x2 equal to 1 1, a column matrix 1 1 is the eigenvector for lambda equal to 2. So therefore model matrix P, we are going to write a model matrix P is nothing but x1 x2, so which is 3 2 1 1. So now find out det P and P inverse. So det P is what? 3 minus 2, which is equal to 1, and P inverse is nothing but 1 by det P into adjoint P. So therefore P inverse is equal to 1 by det P is joint P is nothing but interchange the diagonal elements. 3 1 becomes 1 3, and the non-diagonal elements will be multiplied by negative sign. So this is what P inverse. So therefore D is given by D equal to P inverse AP. So if you find out P inverse AP, it is enough to get the diagonal elements. So P inverse is 1 minus 1 minus 2 3. A is what? A matrix A is minus 1 3 minus 2 4, and P is 3 1 2 1. So we are going to get a diagonal matrix 1 0 0 2. This is nothing but lambda 1 lambda 1, and this is nothing but lambda 2. This is the diagonal matrix, is the diagonal matrix. So this is the way of finding a diagonal matrix. So thank you, all the best for your exam.